Hello everyone, welcome back to my YouTube channel Unfog with Dr. Athar Parveen. This class is going to be the continuation of Modern Physics Part 3. Okay, so let us start the class. Before that, if you are new to this channel, please do subscribe to the channel and also hit the bell icon, because whenever I upload new classes, you will get the notification and you can watch the class as soon as I upload the classes. Okay, and also please do share these classes of Hstr among your friends and other Hstr aspirants. Okay, so let us start the class. In last class, we discussed how Bohr mentioned about the stationary orbits. Having these concepts, one can calculate all the quantities relating to the Bohr's orbit. Like what is the radii of the orbit? To find the radii of the orbit, what you do? You equate this mvr, the angular momentum, to nh by 2 pi. Now with this I can write v as nh by 2 pi mr, right? Or if I do squaring both sides, if I do squaring, v square is equal to nh upon 2 pi mr whole square, right? Now let us recall the Coulomb's force. What did we say? The Coulomb force between two electrons, we said that F is equal to K into Q1 Q2 upon R square, right? We also told that K is 1 by 4 pi epsilon naught Q1 Q2 upon R square. But what is Q1? It is nothing but charge of the electron, right? Q2 is also the charge of the electron. So we can write here as F is equal to 1 upon 4 pi epsilon naught E square. Two electrons, right? Q1 is one electron charge and Q2 is another electron charge. So this one will be E square upon R square. Okay. Sorry, this is R square. But we also have something known as centrifugal force, right? Because we are talking about the circular orbit. So the centrifugal force will be mv square upon R, right? So I can equate these two things so that I will have mv square upon R equal to 1 upon 4 pi epsilon naught E square upon R square. With this I will get a value of v square, right? Correct? This v square will be equal to, here this R will get cancelled and v square will come out to be 1 upon 4 pi epsilon naught. Here I will have E square. This m will go in the right hand side, denominator, mr. Correct? V square will become E square by 4 pi epsilon naught mr. Okay. Now let this be 1 and let this be 2. From 1 and 2, we can equate, right? Because we have V square in the left hand side both sides. So from 1 and 2, we can have nh upon 2 pi mr whole square is equal to E square upon 4 pi epsilon naught mr. Correct? Now if I equate, what all will get cancelled for me here? 1 r will get cancelled with 1 r and 1 m will get cancelled with 1 m. 1 pi will get cancelled with 1 pi and 4 will get cancelled here. So what all is remaining in the left hand side? N square h square upon I have 1 pi, 1 m and 1 r, because it is a whole square, right? In the right hand side I have E square upon epsilon naught. Only so much I have, right? Now I can find the radius of the orbit easily, right? I will do the reciprocal, pi mr upon n square h square equal to epsilon naught upon E square, or r will be equal to n square h square epsilon naught upon pi m E square. Okay, this is the formula for radius of the orbit. See, don't worry about the derivation. They will not ask you anything related to the derivation, but I am deriving here because I want you all to get idea about how you are getting the formula. Okay, the formula for a radius of the orbit. You can see this formula and you can understand that the radius is directly proportional to square of the principal quantum number. Correct? Here in this formula, you know that all are constant, right? H is a Planck's constant, epsilon naught is a constant, Then epsilon naught is actually permittivity of a free space. Okay, I will tell you the value also later. I will tell. Then E is the charge of the electron. All these are constants, right? Only if you write n is equal to 1 here, means for the smallest orbit or the first orbit, if n is equal to 1, then if you substitute all the values here, you will find this radius of the orbit to be equal to 0.529 into 10 to the power minus 10 meters, or it will be equal to 5.29 into 10 to the power minus 11 meters. Or you can also say it as in another unit terms 0.529 angstroms. Okay, this thing is equal to 0.529 angstroms because it is a smaller unit. 1 angstrom is equal to 10 to the power minus 10 meter. Okay, so atom is about 10 to the power minus 10 meter diameter. This double you will do, right, for a diameter. So the diameter of atom will be equal to about 10 to the power minus 10 meter. Okay, these all can be multiple choice questions. So this is how you can derive the quantities related to Bohr's orbit. This is the first thing, so I have derived. I will not derive all other quantities. Like a few more quantities are there which we have to find. We will directly see the relation between that quantity and the principal quantum number. Okay, like we have this velocity of revolving electrons. What will be the velocity? Here what you do? You will relate mvr to nh by 2 pi. With this you will have v is equal to e square by 2nh upon epsilon naught. Okay, this will be the formula for velocity of revolving electrons. We got this by that formula of R. R is equal to n square h square epsilon naught by pi m e square, we told. No, by substituting this we got this formula. Okay, now I can easily say that the velocity of the electron is inversely proportional to principal quantum number n, right? So this is important for us because they will not ask any formula in the examination, but these relations are important. Okay, so electron in the innermost orbit, it will have the highest velocity. Okay, it will have the highest velocity because it is inversely proportional to the principal quantum number. Like that only we can also find the orbital frequency of electrons. Orbital frequency of electrons is inversely proportional to cube of the principal quantum number. Like that only you can find the electron energy, the energy of the electron. This is important. The total energy of the electron means it should be sum of kinetic energy and potential energy of the electron, right? In this, if you want to find the kinetic energy, you know the formula for kinetic energy, half mv square. Here, half and m you write as it is. You write the value of velocity of electron. Just now we saw it, right? It is e square upon 2nh epsilon naught upon whole square. So this will give you m e to the power 4 upon 2 2s are 4, 4 2s are 8. So you will have 8 in the denominator, right? Because you have square for 2 here. So this will be 8 n square h square epsilon naught square. Okay, this will be your kinetic energy. Like that only you can find potential energy also, but you will not have half there. So your potential energy will be same, but you will have 4 in the denominator, n square h square epsilon naught square, and you will have a minus sign, which is important. You will have minus sign in potential energy. Okay, this minus sign is there here because potential energy will be greater than kinetic energy, or in other words, potential energy will be negative because there is attraction of electrons towards the nucleus. Nucleus is trying to attract the electrons, but then because of its equal and opposite force, that electron, it is not going outside, it is revolving around the nucleus. Okay, so you should remember that kinetic energy is positive, potential energy is negative. Okay, now I can easily find total energy, right? What will be my total energy? Total energy will be equal to kinetic energy plus potential energy. What is kinetic energy? me to the power 4 by 8 n square h square epsilon naught square plus what is potential energy? Minus me to the power 4 by 4 n square h square epsilon naught square. Okay. Here if you take all these constants outside as common, you will have half minus 1. Okay. Or you will have minus again here in the answer, and you will have this thing because which you have taken common, right? Me to the power 4 upon, again you will have 8 n square h square epsilon naught square. Okay. So this is your total energy, and this will be negative because potential energy will be greater than kinetic energy. Basically this negative energy, it will signify that electron cannot escape from atom. Okay, this can be a multiple choice question. What is the point here? That negative sign in energy implies that electron cannot escape from atom. So this is about electron energy. Now moving towards the most important thing, which is the frequency of emitted electrons. What did we tell? The change in the energy according to Bohrs model, delta E is equal to E2 minus E1, right? This is equal to NH nu, we told, right? Or if N is equal to 1, you can write it as H nu only, right? Now we found the energy also. What was the energy? It was me to the power 4 by 8 n square h square epsilon naught square, we told, right? So that thing we can write it here now. H nu is equal to E2 minus E1. Okay. After writing the values of energy here, if you take that energy value, the constant values as common. Okay. Let me write it down. me to the power 4 by 8 n square h square epsilon naught square, right? Then minus again minus of me to the power 4 by 8 epsilon naught n square h square, right? But here in place of E2 I will write N2, in place of E1 I will write N1, because E is equal to H nu. Okay, NH nu actually. See, I will write it again. E is equal to NH nu. So E1 should be N1 H nu. E2 should be N2 H nu, and so on, right? So I wrote N1 and N2 here. In place of E1 I will write N1 here. So here I can take all constants as common, right? I will take minus e to the power 4 by 8 epsilon naught square h square. Inside what I will have? I will have 1 by n2 square minus 1 by n1 square. Correct? If I take only frequency in the left hand side, that h will go in the denominator. Here I will have minus me to the power 4 by 8 epsilon naught h square. So here in brackets I will have 1 by n2 square minus 1 by n1 square. Okay. So this thing is there, no. This whole constant is there, no. This whole constant thing, you can change the sign here, right? If I write plus here, me to the power 4 by 8 epsilon naught h square. Here it will become 1 by n1 square minus 1 by n2 square, right? You agree with me, right? I am just changing the sign of both the things. So this will happen. Now in the left hand side, in place of frequency, I can write it as 1 upon lambda or wavelength, because frequency is equal to 1 by lambda, right? It is inversely relating to wavelength. Frequency and wavelength are inversely related. So 1 by lambda is equal to me to the power 4 by 8 epsilon naught square h square into 1 by n1 square minus 1 by n2 square. Now this constant is there, no. This constant is nothing but R, Rydberg's constant. This is equal to 10.97 into 10 power minus 6 meter. Okay. It is called Rydberg's constant. Okay. Now there is another term known as a wave number. This wave number you denote it like this, nu bar. Okay. This nu bar is equal to 1 upon lambda. Now this constant is Rydberg constant, capital R, right? This is R into 1 upon n1 square minus 1 upon n2 square. Okay. So this is a very, very important formula. Very, very important formula. Okay. We found that the electron energy in the nth orbit, this is thing, right? Now here we know the constants also, right? Now this constants, if you substitute, you can get energy. What will be the energy if you substitute it here? Energy En will be equal to one value. You have to remember this value. Minus 13.6 upon n will not change because we don't know what is n. No. If n is 1, you will write 1 there. If n is 2, you will write 2 there. Correct? So n is not a constant. That is only one variable here. So this is in electron volt. Unit of energy here will be electron volt, and energy is inversely proportional to square of this n. Okay, the principal quantum number. Okay, now with this I can say that if the electron is in K shell, what will be my n? N will be 1, right? If n will be 1, what will be my energy? My energy will be even, right? So here I can put n is equal to 1 minus 13.6 upon 1 square. Correct? EV. Or this is equal to minus 13.6 EV. Correct? Like that only if the electron is in a L shell, n will be 2, right? If n will be 2 means what will be E2? Here in place of n, you will write 2. Correct? E2 will be minus 13.6 upon n square, or n square means I will write 2 in place of n. Correct? So here I will write 2. So it will be 2 square, or this will be equal to minus 13.6 upon 4. Minus 4 3s are 12, right? Minus 3.4, around this value. Okay, like that only you can do for M shell also, you can do for N shell also. Okay, your values will go on changing till you can also write till n is equal to infinity. At that time your E0 will be 0 electron volt. Okay, so this is how you can find the electron energy levels in hydrogen atom using all the constants. Only thing you should know is the shell. If you know the location of the shell, means it is K, L or M or N, then you will know N, right? So you can find the orbital energy. Okay. Now this is the general expression for wavelength or wave number, right? So this will explain completely everything about the hydrogen spectrum. In hydrogen spectrum, there are few important radiations like Lyman series, Balmer series, Paston series, bracket series and P-Fund series. Lyman series means in this series, no, all wavelengths which are emitted when electron jumps from one outer orbit to first orbit. Okay, means from outer orbit to K orbit. That will fall in Lyman series. Means for K orbit, what is N? It will be 1, right? So N1 will be 1 and N2 will be 2, 3, 4 till infinity. Okay, like that only for Balmer series, I will write it here. N2 will be 2, 3, like this it will go till infinity. Okay, like that only for Balmer series, electron will jump from outer orbit to L shell. So here N1 will be 2. Okay, and N2 will be 3, 4, 5. And for Paston series, electron will jump from outermost orbit to M, right? So what will be N1? N1 should be 3. In bracket series, electron will jump from outermost orbit to N shell, right? So it will be 4 here, N1. Okay, and again next shell for P-Fund. Okay, so N1 will be 5, like that. Okay, so I have a table here. For Lyman series, value of N1 will be 1 and value of N2 will be 2, 3, 4 till infinity. For Balmer, value of N1 will be 2, value of N2 will be 3, 4, 5 till infinity. Means it is, the number will change. You have to see here. As the series will increase, value of N1 will increase and value of N2 will also increase. Okay. And what is the position of the spectrum? Lyman series, it will fall in a ultraviolet region, and Balmer series will fall in visible region. Paston, bracket and P-Fund series, they fall in infrared region. Okay. So if you want to find the wavelength, let us take example of Lyman series. What is the formula? 1 upon lambda is equal to R into 1 upon N1 square minus 1 upon N2 square, right? So for Lyman series, N1 will be 1 and N2 will be 2 right now, okay, to start with. So 1 upon lambda will become R into 1 upon 1 square minus 1 upon 2 square. So this will be equal to R into 1 minus 1 upon 4, or this will be equal to R into 4 minus 1 by 4. It will become 3 by 4. So what we have in the left hand side, we have 1 by lambda, right? In the right hand side, we have 3R by 4. So my wavelength will become 4 by 3R. Okay, this is how you can find the wavelength for particular series if you just know what is the value of N1 and N2. Okay, you take it as assignment, you do it for Balmer series, Paston series, bracket series and P-Fund series also. Okay. Now remembering these series in order is very important, right? Or else you will miss the numbers N1 and N2, correct? So to remember these series, I have made one trick. This I have made it by myself. It is little funny. It is like a low blood pressure, again blood pressure, okay? Low BP, BP. Just you have to remember that Balmer series will come first and bracket series will come afterwards, okay? And P-Fund is different only. You will not get confused here. Only Balmer is first and bracket is later, you have to remember. Low BP, BP, okay? Low BP, BP. L for Lyman series, B for Balmer series, P for Paston series, B for bracket series and P for P-Fund series. So you should remember this L, BP, BP and this will be 1, 2, 3, 4, 5. Okay. So don't forget this order. Okay. Now this was all about the Bohrs atomic model. Now there are some limitations of a Bohr atomic model. This is very important because these points may be asked as multiple choice questions in your examination. Okay. So what is the first limitation? It is that the Bohr atomic model, it is violating the Heisenberg's uncertainty principle. Okay. This Bohr atomic model, it will consider electrons to have both known radius and orbit. Means at a time position and momentum, it is not possible to measure, right, from Heisenberg's uncertainty principle. So this is one limitation of Bohr's atomic model. Next is that Bohr's atomic model theory, it made correct predictions for smaller sized atoms like hydrogen, because it took example only of hydrogen, but poor spectral predictions were made for larger atoms. Okay, when you consider the same concepts for larger atoms, predictions were not as accurate as it should be. And then Bohr's atomic model, it failed to explain two important phenomena known as a Zeeman effect and a Stark effect. What is Zeeman effect means? If spectral line is split into several components and presence of magnetic field, then that effect you call it as Zeeman effect. And if spectral lines get split up into fine lines in presence of electric field, that effect you call it as a Stark effect. Bohr's atomic model could not explain both Zeeman effect and Stark effect. Okay, so these are the limitations of Bohr's atomic model. Now let us solve multiple choice questions based on Modern Physics Part 3A class, that means the previous class and this present class. Okay, if you have not watched Part 3A class, then please pause this video right now. First watch Part 3A class and come back to solve these multiple choice questions, because you will not be able to understand the solutions for these questions if you have not watched Part 3A class. Okay, so let us start solving these multiple choice questions now. First question is, Rutherford's alpha particle scattering experiment was responsible for the discovery of. It was responsible for the discovery of course, atomic nucleus. Next question, an alpha particle is also known as, of course it is also known as doubly charged helium ion. Okay, so an alpha particle is a doubly charged helium ion, that is a He2+. Next question, which of the following statements about the electron is incorrect? It is negatively charged particle, the mass of the electron is equal to mass of the neutron, it is basic constituent of all atom, it is constituent of cathode rays. All this is correct, but the mass of electron, it is not equal to mass of neutron. In fact, mass of electron is 1 by 1/836 of mass of proton or neutron. It is very much smaller than proton or neutron. This point I didn't say in class, but then you never know, they may ask this type of a question also, because we are talking about atomic models in this class, right? Okay. Next question. Why was the Thomson's model of an atom failed? Thomson's atomic model was a very initial model. It could not explain many things like the negative charges and positive charges interaction between each other, and it could also not give idea about this separate discrete energy levels. Correct? Many things it did not say. You can read the sentences properly and you take the correct answer in this type of question. Okay. Next question. Which of the following statement is incorrect about the structure of an atom? Whole mass of an atom is concentrated in the nucleus. The atom is an invisible particle. The atom as a whole is neutral. All atoms are stable in their basic state. So which of the following is incorrect about structure of an atom? It is that atom is indivisible particle and all atoms are stable in their basic state. So these are incorrect statements because many atoms are not stable in their basic state. That we saw in radioactivity also. Correct? And of course atom is divisible particle because there are more subparticles, right? Electrons and protons are there. Okay. Next question. What was the source of alpha particles in Rutherford scattering experiment? Of course it was a helium nucleus. Next question. Which scientist gave the concept of fixed energy levels around the nucleus? It is Niels Bohr. Next question. What prevents an atom from being collapsed? Of course, movement of electrons in discrete energy levels. Next question. The electrons present in the outermost shell are called? They are called valence electrons. We did not talk much about valence electrons here, means we did not use this word, but we talked much about the electrons in the outermost shell, right? So they are known as valence electrons. Okay. Next question. An alpha particle contains, of course it contains 2 positive charge and 4 mass unit. Next question. The force that allows electrons to move around the nucleus is, it is electrostatic force. Okay. Next question. The angular momentum of electron in nth orbit is given by, of course, nh by 2 pi. According to Bohr's atomic model, the radius of the orbit is directly proportional to n square. According to Bohr's atomic model, angular momentum of orbit is multiple of, it is h by 2 pi. See, multiple of is h by 2 pi. Means it is n h by 2 pi. Okay. Next question. When electrons move from a lower energy level to a higher energy level, energy is, of course, it will be absorbed. It is moving from lower energy level to higher level energy, right? So it needs energy to go from lower to higher energy level. So it will have to take energy from its surroundings. Okay. Next, Bohr's radius is equal to, of course, 5.29 10 to the minus 11 meters. Next question. The energy of each orbit is, it is fixed. Okay. According to Bohr's atomic model, the energy of each orbit is fixed. Next question. When electrons move from higher energy level to a lower energy level, energy is emitted because they are moving from higher to lower, right? If they are going from higher energy level to lower energy level, they will emit certain energy. Okay, they will not need much energy, so they will emit certain energy to go to the lower energy level. Okay. Which of the following spectrum series of hydrogen atom lies in ultraviolet band? I gave you the table, right? It is a Lyman series. Okay. Similar question they have asked in Hstr 2015 also. When an electron jumps to the second orbit, n1 is equal to 2 from any higher orbits, n2 is equal to 3, 4, 5. Then the obtained spectral series is, it should be Balmer series. See the table. Okay. So this table is very, very important for you all. Okay. So this finishes this part of modern physics chapter. Okay, I really hope that you all enjoyed attending this class, and this is a very, very important class. Okay, and before signing off, I want to remind you all, please do like, share and subscribe to my channel if you want more such videos. Okay, thank you. Bye.